Hello, everybody. Let's look at week 2, number 7, add binary. Oh, I have it open right here. Number 67, add binary. Given two binary strings, A and B, return their sum as a binary string. Example 1, inputs A is 1, 1, and B is 1, and the output is 1, 0, 0. So if we remember, the way that we add it is you'd carry the 1 here, where this is the maximum of 2, carry the 1 here, and this becomes 100. Not 100, but 100. Example 2 would be this number here, 1010 and 1011. Same situation, you're adding it, but the maximum number is 1. Right, and then that's the output. Let's think about how we would do this in code. In code, we're given two strings, A and B, and we're not exactly, can't exactly line up a string the way that we're doing here with the diagram, right? So how do we iterate through this string? Well, typically if you're given a string and you want to iterate through it, so for digit in A, what's going to happen is you're going to get the first number, the second, and the third, and that's what a for loop will do for you in Python. But the thing is, we want to iterate from the lowest digit first. So we actually want to iterate from this right side digit first, right? How do I indicate the right side here? I'll make this green. We want this green to be the first thing that we add. So how are we going to do that? How are we going to iterate backwards? Now this is not very common outside of trying to do a mathematical equation, right? But this is the problem. And you must remember that just because, you know, we know the lengths of these here, these lengths could vary massively, right? And when lengths vary and you're doing addition, you actually have to line them up, right? You have to line them up on the right side. So we're going to think of some way to iterate through both A and B, where A and B can iterate together from the rightmost side. So when A gets to the 5th position here, it's only B and possibly a carry going forward, right? So that's a consideration that we have to make. One thing we can do is instead of trying to iterate from left to right, we can reverse both strings, right? And what does that give us? So let's go ahead and delete this here. If we reverse both strings, so I'm going to put this as an, I'm just going to say R here, reversed. This becomes here, this becomes here, this becomes here, and this becomes here. And then the same thing on this side. Well, now when we iterate, with a regular for loop, we're going to use a pointer, and when we iterate, it's actually going to be the right direction, or it's going to be the, the right ordering. We're going to go from the rightmost side, or what was the rightmost side, and as we iterate through it, we'll go to the end, right? And that's something we can totally do. And when we talk about the difference with the length, what we can do is we can just check to see if, here, if we're out of bounds, right? If we're out of bounds, just go ahead and skip it. So let's think about some code here. So a function here is a solution. And let's say we have A reversed. And let's just call reversed here, or, whichever Python method is the right one. It could be reversed with the ed instead of a e. One of these returns a list and one of them doesn't. Okay, so we have A reversed and B reversed. And we want to iterate, right? This red arrow right here. We want to iterate. Let's see if I can capture just a red arrow. I could not. Okay. Let's, maybe I can group this. How do I group this? Boom. Okay, grouped. So I want to iterate, right? And when I get to here, I want to be able to know that it's out of bounds. So it would be really good if I can iterate with from 0 to the longest list, right? So I'm going to go ahead and say the max length between these two is max of length of A and the length of B, right? And for I, in range 0 to the max length, we want to do some iteration. That's our red arrow right here, right? And what do we want to do? So how do we add? We're going to need some type of carry, right? A carry can start as 0. So if it's 1 plus 1, we're going to carry 1 to the other side, right? And we need some type of results. So I'm going to go ahead and say results here. And I'll just make that a list, and we're going to append to this list. So for range I in this range, let's check if it's out of bounds. Let's check if it's inbounds. So if A inbounds, if B inbounds, so if A and B are inbounds, then what we want to add to result is, so results.append is, you know, the additive nature. So the element from A, element from B, and the carry. So we actually need to check if this needs to be another carry. So this is a key thing. This is a super key point, right? So if A and B are in bounds, before we do this, before we append, we need to take in consideration what is the sum, right? So the sum is the element from A plus the element from B plus the carry. So let's think, if it's 0, what happens? If it's 0, we just do 0. If it's 1, we just do 1, right? If it's 2, however, we want to bring this down to a 1. Sorry. So if it's 2, it's a 0, right? So 1 plus 1 in the binary sense is 0, right? If it's 3, right, which is 1 plus 1 with a carry, so let's use this as an example, right? So if I'm doing 1, 1 plus 1, 1, then this becomes 1 with a carry, right? And this, we can't make this all the way to 3, right? This becomes 1 with another carry, and then this becomes 1, right? Totally makes sense? Okay, so if there's a 3, then I'm going to convert that into a 1, and then I'm going to make sure that I put a carry, right? Okay, so the sum of these is this value. So if the sum is larger than or equal to 2, then we want to make sure that the carry is equal to 1. Else, the carry is equal to 0, right? We do not want to carry. And then we do results append the sum. Okay, so that's if A is in bounds and if B is in bounds. And I realize this might get a little wordy, so else if, only A is in bounds, do the same kind of summing. Else if only B is in bounds, do the same type of summing. And then if they're both not in bounds, then we're out of it. We still want to add the carry if it exists. So if carry equals 1, results, append 1, and then we eventually want to return results. And we have to reverse it, and then I guess we can join it as well, and that becomes a string. Okay, so that was a lot. So, it's not a tricky problem, but code-wise, it can get a little confusing, right? You have to do a lot of reversals, and let's think through the time complexity of our reversals. It's O of n every time we reverse, right? So let's check. I just want to make sure I have in my head the reverse function correct. Reversed. Okay, let's check case 2. And I just want to make sure reverse is correct here. Okay, so string object has no attribute reversed. Okay, I'm going to look up this docs real quick. All right. Looks like the way to do this. And go ahead and delete all these is : -1. I would have never guessed that. But I guess it makes sense. Okay, so B reversed, A reversed, and let's iterate through these. The max length is going to be the maximum of these two. So the length of A could have been A reversed as well. The length of B. I'm going to have a carry here, and it's going to keep a results array. Could be called digits backwards as well. So for I in range O to max length, we're going to do some logic, right? And let's just print these out just to get a sense of it. You won't always be able to print. Sometimes at Google, you'll actually just be given a Google Doc. But this is it, right? So this is length 4. This is also length 4. And we're iterating through the indices 0, 1, 2, and 3. So 4, right? And what does it look like when it's uneven? Well, you're still going to iterate through the indices, right? Here. So we can go ahead now and get the value. Let's think about just getting the value at A. So A value at this index would be some number. It would be A reversed at this index I. If I is smaller than the length of A, right? Else, let's just say this would be 0. And B, the value at B would be the same thing. It would be B reversed at index I, but only if I is less than the length of B, right? Else this is 0. So what does this mean? Let's think about printing both of these, right? So in this example, we're going to, so this is index I. We're going to print, I guess this was not the perfect way to do it. Maybe we can do it like this. So this would be, okay, great. So this would be I, and then A, and then B, and then I, and then A, and then B. So what do we see here? A is this 11, right? Oh, sorry, we're printing the full string. We want to print A val and B val. So A val should be 1, 1, right? Because that is A. It's going to be 1, 1. B val should actually be 1, 0, right? Because there's only a 1 here. So this is perfect. This is exactly what we need for this. If A inbounds, if B inbounds, we actually don't need that anymore, right? We can go ahead now directly calculate the sum with the value of A and then the value of B plus whatever carry value comes from before is now the sum of, so sum is reserved in Python, so we're not going to call this sum, but we can call this maybe current sum or digit sum, right? And our inequality here still applies, where if the current sum is larger than or equal to 2, right? If it's 2 or if it's 3, then we're going to go and set the carry equal to 1, right? We want to make sure we do that carry. And this is just regular addition. Or else carry is 0, right? And at this point, we also want the cur sum to change, right? So let's think about this right here, right? We want, if it's 2, for it to go to 3, or if it's 2 for it to go to 0, the cur sum, and if it's 3 for it to go to 1, right? So that's carry here. I'll also say cur sum equals, so I'll make a change here, equals 0. And here, oh sorry, I'll do this outside of it. So if cur sum equals 2, then we can go ahead and make it 0. I guess I can put this in here. Right? Else if cur sum equals 3, and it'll never be 4. There's no way for it to be 4. Cur sum equals 1, right? And then we want to append this to the digits backwards variable that we have here. All right. And this should go all the way through to the end, right? So I'm just going to print this as an example so it's easier for everybody here to see it. When you're in an interview, you will not have this chance to actually do this printing, or sometimes you don't, right? So the index here is I, A equals this A dot val, B equals this B dot val, and I guess carry equals this carry, and then I can go ahead and print cur sum is cur sum, and then, you know, let's just imagine that the code in these control flows work correctly, and does not work correctly if you're missing the colon. Okay. Also does not work correctly if you're missing the string to int. Definitely important, right? Because if you're using an index of a string, you're going to get a string. If you set it to an int and you save it as an int, now every time we reference a val or b val, it's going to be an int. All right, so index is 0, a is 1, b is 1, carry is 0, right? So we add that together, and that's a 2. And then for index 1, a is 1, b is 0. The carry is now 1 because we had that 2 from before, right? Cursum is now 2. And I guess I should have added an output here, but you know, at the end of this for loop, if there is a carry, so if carry equals 1, digits backwards, append 1, and then at the end of the function, we want to return digits backwards, and we want to join this, and we want to reverse it, and then we want to join it. So let's see what would happen if we ran this. Right, so the list, it doesn't have join in this way. That's a JavaScript notation. If you take empty string and you join it with this list, this should be the equivalent, but it's not a method on the list. Just kidding, string instance, but int found. So this is funny, right? We're appending the cursum as an int. So if we need to return a string, so if we do need to return a string, we actually have to convert it back, right? So this int needs to be converted back to a string. This is quite, I wonder if this is a realistic question to get, because there's a lot of parts of it that are not super testing data structures and algorithms. It's more testing the ability to work with your language. Make sure to get rid of these prints. So the coding part was a little bit frustrating if you're not familiar with your language, and the logic part was actually quite easy, right? We did this pretty quickly, and if you have some intuition for addition and binary numbers, you can kind of reason out how you would do this in diagram, turning it into code, because you have to reverse the string and do all this adding, converting it into an int, converting it back into a string, and then re-reversing it. It's harder in code than it is in theory. In theory, it was actually quite easy, right? We can just easily draw this out. So this is a type of problem where you need some practice just programming it. I'd encourage everybody to, if you have time, honestly, skip this question. But if you want to practice it, just practice this question a couple times to make sure you have some of the type conversions, reversing, getting the max, all of that. In terms of complexity, this is O of n. We have to go through both strings and add them. We also did the reversal step and then the re-reversal step. So it's like 4 of the O of n operations, but the 4 is a constant, and that's going to get basically ignored in the time complexity analysis. All right, everybody, thanks a lot. Please like and subscribe. Leave any comments for any questions you would like to do that is outside of this ordering that I'm going through for Grind 75. Go ahead and check this off. Thanks again.